A1, we're going to do part A2, which is finding the solution to this homogeneous system with the eigenvalue, solving the eigenvalue problem. So finding the eigenvalues, the eigenvectors. So let's go over to Matlab and let's show you how to do this. So this is percent, that's going to create a new block, exercise 15. And now I'm going to clear all previous output, clear all old variables, and you do that with the command clear all. And then I'm going to define the coefficient matrix for that system. So the coefficient matrix for that system, I'm going to call it A. I need the square brackets, and let me remind myself of what that was. Well, we had -3 over 100 and 1 over 100. That's the first row. The second row is 1 over 50. Second row is 1 over 50. And -1 over 50. I put a semicolon because I don't want it to output. Now what do we want to do? Well, remember, we want to solve the system. So we want to find the eigenvalues and vectors of the system and of the matrix, of the coefficient matrix. So how will we do that? Well, first of all, I want to check that they are repeated, they're not repeated roots, because then the Jordan doesn't work. So I'll press Control Enter. And here, I noticed that I didn't put a space here, so the dimensions weren't working, and Matlab was telling me that. Now that I correct it, I see, well, I get two distinct values. So that's good. Now another, actually, I'm not going to do that yet. So now that I know, I can use the Jordan. And I know the Jordan is going to output two things, so I need a matrix output. And the first thing that it's going to output is the eigenvectors. The second thing that it's going to output is the eigenvalues. So we can just write it like this, and it'll give us the vectors and the values. And now I want to press Control Enter and see what we get. So we get these numbers. Okay, the vectors is okay. And here we have some fractions. We'd like to see these we have some decimals, but we like to see these as fractions. So one way to do that is to write here, asking Matlab to output fractions. And format rat should do it. So as we look here, we see that now we have those same values, but in terms of fractions, which is kind of nicer to see. So now we can already define the general solution, because with each eigenvector and eigenvalue, we get one solution. The general solution is going to be C1 multiplied by the first eigenvector, which in this case is -1 and 1, and then multiplied by e to the, this value over here, -1 over 25 times t. We don't like the f there. And then we're going to add C2 times the second eigenvector, which is 1/2 and 1. And then I multiply by e to the -1 over 100 times t. And I don't want it to output, but I want to check that it is correct. So let's see. Right there, what do we have? We have C1 times a vector -1 and 1, exponent of -1 over 25 times t, plus C2 times 1/2 times 1 times the exponent of -1 over 100 times t. Okay, well now Matlab is not going to know what C1, what t, C2 are. So let's define those variables, sims, so C1, C2, and t. Now that we have those defined, we have our general solution, And that's the end of part A, because part A, actually, this is part B. So because part A was only about finding the matrix, and this is finding the solution, and then it gives you the initial value. So I apologize for that. See, as you see here, just write the matrix in matrix form. So this is our solution to part A. Then here it says, use the eigenvalue method, which we did with the Jordan, and to solve for the linear system subject to this initial condition. So that x of sub 1 of 0 is equal to 20 and x sub 2 of 0 is equal to 5. Now, what does this mean in context? Well, remember what x sub 1 is. X sub 1 is a function of time, and it represents the amount of salt in tank A at any time. So it's saying, hey, at t equals 0, at the beginning of this model, I have 20 pounds of salt in tank A and 5 pounds in tank B. So we can write this into our Matlab to find C1 and C2. So finding the specific solution, well, we need to solve a system. It's going to be the solution x of 0 is equal to 20 and 5. And we can use the solve function here. The first arguments are whatever the functions you want to solve, the equations that you want to solve. The second argument is the variables that you want to solve for. In this case, you want to solve for C1 and C2. And then the third ones are optionals. Now, this is going to output at least 2 results, one for C1 and one for C2. So I need to assign it a matrix output, and that's going to be C1 sol and C2 sol. And once we have this, I can put a comma here. I can actually redefine the solution, because now we have those initial values. So I can just take this, copy it, paste it over here, and then I'll write whatever the solution is. This is assuming they only have one answer for each, otherwise you'd have to do some indexing. Press Control Enter, and you get an error. So I wonder what my error is. Perhaps I didn't put a T here. That might have been the case. Yes. So they gave me this. And then here I put a semicolon so it didn't output it. But if I take out the semicolon, it'll output my solution for this model. And here is my solution right here. Now, if we want to check it, we can go back, plug it in, find the derivative, and set it equal to a times x, and see if we get equal to the left and equal to the right. I hope this was helpful, and this is actually the end of part B. We'll go again with part C of this problem. I'll see you there.